Thank you for joining us today. We're excited to present a compelling showcase on how real-time technology can empower financial institutions and enterprises to act faster, smarter, with greater precision. Today's demonstration focuses on real-time fraud detection and prevention, a critical use case for banks looking to protect their customers from increasingly sophisticated fraudsters. But this is just one example of what's possible by combining three powerful technologies together. Precisely CDC Connect to stream change data directly from mainframes. Confluent's real-time event streaming and AI analytics capability, and Databricks with Confluent's Tableflow integration for advanced analytics and AI. We're showcasing a blueprint that can be applied across a wide range of high-impact scenarios, whether it's fraud detection, real-time risk assessment, operational monitoring, or personalized customer engagement. This architecture unlocks real-time insight and action, from legacy system all the way to AI-driven decisions platform. Let's explore how this end-to-end solution works and how your organization can extend it far beyond fraud prevention. Before we dive into the live demos, here is a quick overview of what we will be showcasing today. We have broken the session into three focused demonstrations, each highlighting a core capability of our real-time data and analytics architecture. The first demo is a real-time detection using Confluent. We will start with a look at how Confluent enables real-time streaming processing to detect suspicious activities the moment they happen, crucial for high-stake use cases like fraud prevention. The second demo is a real-time mainframe modernization. We will show how legacy mainframe data can be brought into life using Precisely CDC Connect, streamed through Confluent, and landed into Databricks using Tableflow, enabling real-time analytics and AI without ripping and replacing your core system. The third demo is a real-time AI inferencing using Confluent. We will demonstrate how AI models can be integrated into the streaming pipeline to make intelligent decisions in real time, from risk scoring to anomaly detection. We will show how AI inferencing at scale is now possible directly within the Confluent ecosystem. Together, these demos illustrate how a unified streaming architecture can power not just fraud prevention, but a wide range of high-impact use cases across industry. Before we get started the demo, please allow us to introduce ourselves. GoodLabs is a business-first AI engineering studio and a trusted engineering partner of Precisely, Confluent, and Databricks. Our software engineering team specializes in mainframe integration and real-time analytics technologies, including Confluent, KStream, Flink, and Databricks. We work hand in hand with our dedicated AI research team of PhDs to deliver streaming AI solutions that leverage advanced technology to solve our customers' most complex and high-impact challenges. Let's start with a warm-up demo to show how we can detect account takeover fraud in real time using Confluent and Flink. Fraudster can take over an account in as little as 5 minutes, often using techniques like evil proxy to bypass even the two-factor authentication. That's why real-time analytics technology like Confluent are critical to staying ahead of these threats. In this demo, we will simulate a real-world attack scenario using our simulated banking system, Good Financial. First, we will ingest live login events, device metadata, and transaction activity from the legitimate user into Confluent in real time. At the same time, we will capture the fraudster session's activity as they begin to take over the account. Then, using Flink's powerful streaming processing, we will join and correlate these event streams to detect suspicious patterns, such as impossible travel speed between login locations, or a sudden device change just before a high-value transaction. With this setup, we can identify and respond to account takeover attempts within seconds before any irreversible damage is done. The regular bank customer, as the victim of the fraudulent activity, will first log into the online banking via the evil proxy platform. They will enter the password, and even with 2FA bypassed. After login, the login event sent to Confluent, and we can see the login profile information. The IP address of the victim is 174.95.90.23, latitude is 43, longitude is -80 with operating system as the macOS. And we can see the login event in the control center. Then the fraudster will extract the cookie information from the evil proxy, paste that into the online banking platform to take over the account silently. While the victim is performing the regular banking activities, the fraudster simultaneously accessing the bank session and head right into the payment transfer to steal the money from the victim. And we have captured the fraudster session, and we can see the IP and location have changed. And thanks to our Flink job, was able to calculate the traveling speed to be 18,000 miles per hour, which is impossible to achieve. Our control center provides the immediate alert to indicate the victim session has been compromised. Now that we have seen how powerful and simple Confluent and Flink detect suspicious activity in real time, let's look at how we bring the same speed and intelligence to payment transaction in Mainframe. Many banks still rely on DB2, IMS, or vSAM on mainframes to process massive volume of transactions. The challenge is getting that data into modern analytics platform in real time. In this demo, we will show how Precisely CDC Connect streams mainframe change data capture into Confluent, Confluent Tableflow pushes that directly into Databricks, and we can perform real-time analytics and anomaly detection on payment transaction at scale. Separately, we will also show how seamless schema evolution is. When we change the schema in the mainframe, say, adding a new field, it flows automatically from Precisely to Confluent and then to Databricks with zero manual effort. Let's dive into the demo. In this demo, our simulated banking system writes payment transaction into a DB2 mainframe database. We use Precisely CDC Connect to stream those changes in real time to Confluent. To sync this data into Databricks, we leverage Confluent's Tableflow, which as of today support only append-only mode with Dabazium after state-only format. Since Precisely emit full CDC event, we insert a lightweight replicator with a single message transform to convert those events into after-image-only format. This transform stream is written to a dedicated topic with Tableflow enabled, allowing us to stream directly into Databricks for real-time analytics. With this setup, mainframe data flows into Databricks seamlessly, enabling anomaly detection and insight with zero manual intervention. Let's take a look. We will go into our simulated banking platform making payments, where the banking platform will simulate the bank's payment processing by sending the payment transaction into our mainframe DB2. We will make 5 transactions here with various amounts. Let's check it out our mainframe DB2 instance. As we can see, we are able to see all the 5 payment transactions in our DB2 mainframe instance. Let's switch it over to Confluent. We're able to see the Precisely CDC Connect send all the 5 payment transactions into Confluent's payment transaction topics. As you can see here, we have the full CDC record with the before and after image. And our replicator takes the payment transaction full CDC record with the single message transform, converts into a Debezium after state only Tableflow compatible CDC record to the payment transaction Tableflow topic. As you can see, this topic is Tableflow enabled to sync the data into the iceberg. Let's switch to Databricks. And here you can see we can access all the payment transactions from Mainframe, now residing inside Databricks thanks to the powerful Precisely CDC and Confluent Tableflow technologies. Now that we have seen how easy it is to stream mainframe data from DB2, IMS, vSAM into Databricks using Precisely CDC Connect and Confluent Tableflow, let's take it one step further. I want to show you a truly powerful capability, schema evolution with zero touch. In this demo, we'll go directly into the mainframe database, add a new column to the existing table, and insert data that includes this new field. Then we'll observe how the schema change automatically propagates from the mainframe through Precisely into Confluent and finally into Databricks without any manual configuration or downtime. Let's take a look at how seamless this real-time schema evolution really is. We will first alter the table in our mainframe DB2 instance to add a new column called evolve_18, which is a varchar 1. Then we will insert a few new records with the value capital K in there. So as you can see, we have added the new column evolve18 and then putting a capital K as the value. Now let's change the primary key, adding the first record first. And then change it again, insert another record, and change it again, insert one more record, and one more, and we will insert the last one here, and there you go. Now let's switch to Confluent. With Precisely CDC Connect, the new records with the new column are now in the payment transaction topic with the full CDC before and after image. And like before, our replicator transformed these full CDC records to after state only records with the new column evolve_18 in the payment transaction Tableflow topic. Let's switch to Databricks. With the Tableflow, we have synced all the new records with the new column evolve_18 all the way to Databricks with no human intervention, thanks to the magic from Precisely CDC combined with Confluent's Tableflow feature. Let's quickly recap the key technical insight from what we have just seen. Tableflow is the bridge that streams real-time data from Confluent directly into Databricks. Currently, Tableflow supports append-only mode using the Debezium CDC format with after-state only enabled. That means only the final state of a row is processed, no before or after images. To make Precisely CDC Connect compatible, GoodLabs is developing a lightweight extension for Precisely CDC Connect that can transform full CDC messages into after image only format, making it fully usable with Tableflow. We also demonstrated Tableflow support for schema evolution, allowing schema changes from mainframe to flow all the way to Databricks with no manual intervention. On the Databricks side, Iceberg tables are supported for Tableflow, and Delta is in early access right now. Schema changes must be nullable with no default value to be compatible. Delta Lake support on schema evolution is in the works and expected in the near future. Additionally, schema evolution currently works with the Databricks managed Iceberg under Unity Catalog. External Iceberg tables are not yet supported by Tableflow yet. This setup gives you a robust and future-ready foundation for streaming analytics with full support for real-time data, schema evolution, and enterprise-grade governance. In this final demo, we are showcasing how real-time AI inference can be embedded directly into a streaming pipeline to detect check fraud at the point of deposit. Using our simulated banking platform, we will walk through an online check deposit scenario. As the users submit a check image, the data is streamed into Confluent and processed using Flink. Flink triggers an AI inference call to a large vision language model hosted in Azure ML. Unlike traditional models that rely on strict field boundaries or OCR zones, this model views the check holistically, exactly like human being, extracting all the textual content and understand the context to identify the payee, the amount and memo, and other critical fields accurately. This avoids common errors seen in the traditional ML system where important information is misclassified or missed entirely. Based on the model's output, we can validate the check in real time and take immediate action, approve, flag, or reject, all seamlessly within Confluent and Flink pipeline. We will go into our simulated banking platform on the check upload. We will simulate the check deposit process by uploading a check image. Now our bank username is Jimmy Page. Now, and as you can see, we are attempting to deposit a check with a payee name Ken Rosewall. Let's deposit the check and see what happened. After we upload the check, we will send the check image into Confluent and using a Flink SQL to trigger the AI inferencing for our large vision and language model deployed in Azure ML to extract all the textual information and use the contextual information to separate out such as payee, amount, and memo. And now we see the response from the check verification indicating unauthorized payee name does not match your account name. Let's take a look at the Confluent side. We can see the check topic has image data encoded in base 64, and let's hop on to the check inference topic. And we can see all the relevant information extracted out by the large vision and language model correctly with the name mismatching the account holder name. Thank you for watching our presentation. We hope this gave you a clear view on how powerful and practical it is to combine Precisely, Confluent, and Databricks to modernize mainframe system and unlock near real-time analytics. From streaming mission-critical data out of the mainframe, to detecting fraud in real time, to applying AI for intelligent decisions, we have shown how these technologies work seamlessly together to solve high-impact problems. We appreciate your time and look forward to helping you bring real-time intelligence into your business. Thank you.